Hey everyone, in this video we're going to learn how to simplify a square root. Before we get into it, we're going to first talk about the components of a square root or a root in general. So to start, the symbol is called a radical. The expression inside of the radical is a radicand, and the value right here is the index. If there is no value there, we assume it to be 2, which is exactly the case with the square root. If it's a 3, we have a cube root, 4 we'd have a fourth root, and would build from there. Now in general, remember what we're trying to do when we evaluate a square root, right? The square root of 25 is 5. Why is that? Because 5 squared equals 25. We're trying to find a number when multiplied by itself gives us the radicand. Okay, so we're going to keep that in mind as we go through simplifying square roots. A squared expression is in simplest form when no radicands are divisible by perfect square factors other than 1, no radicands contain fractions, no square roots appear in the denominator of a fraction. In this video, we're going to focus on that first bullet point. No radicands are divisible by perfect square factors other than 1. The other 2 bullet points we're going to talk about when we learn how to rationalize the denominator in the next video. So in order to simplify a square root, we need to find the largest perfect square which will divide evenly into the radicand. To make our life easier, it's going to be helpful to have a list of perfect squares for us to reference. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225. Now typically, that's pretty sufficient for simplifying square roots. Anything higher, we're typically going to have access to a calculator, or it's going to be a factor or a power of 10 that we can figure out pretty easily. So using this list of perfect squares, let's look at simplifying a few square roots. So the first, square root of 100. So always, the way we want to start is checking if the radicand is a perfect square. That's going to make our life pretty easy. So in this case, 100 is a perfect square, so the square root of 100 is 10. So again, it's just a nice reminder that when we're trying to evaluate a square root, we're looking for a number when multiplied by itself gives us the radicand. So now looking at the square root of 12, 12 is not a perfect square. So how can we simplify this further? So the first thing I would do is list out the factor pairs of 12. So that's 1 times 12, 2 times 6, 3 times 4. And then we're going to go through these factor pairs and find the factor pair that contains the largest perfect square. So 1 and 12, 1 is a perfect square, but that doesn't help us break down 12 any further. 2 times 6, neither of those are perfect squares. 3 times 4, that's the factor pair we're going to use. So then we have square root of 12, and we're going to rewrite it as the product of 2 square roots. So we're going to rewrite it as the square root of 4 times the square root of 3. So we write the perfect square factor first, and then the other factor. Now we take the square root of 4, which is 2, times the square root of 3. So then we can say that the square root of 12 is equivalent to 2 times the square root of 3. Now, in this example, it worked out nicely, but let's say you had a different number and you had all these factor pairs, and none of the factors were perfect squares. Well, then that means that the expression that you were given is in simplest radical form, and we don't go any further. So let's look at the next example, which is the square root of 27. So again, we'll start by listing the factor pairs of 27. So we have 1 times 27, 3 times 9. So looking at this factor pair, 3 times 9, 9 is the largest perfect square factor of 27. So we're going to rewrite the square root of 27 as the product of the square root of 9 times the square root of 3. The square root of 9 is 3 times the square root of 3. So the square root of 27 is equivalent to 3 times the square root of 3. Next one, the square root of 72. Again, we'll start with our factor pairs. So 1 times 72, 2 times 36, 4 times 18, 6 times 12, and 8 times 9. So there we have all of the factor pairs of 72. And looking at each set of factor pairs, 2 times 36 is the factor pair that contains the largest perfect square. So we're going to rewrite the square root of 72 as the square root of 36 times the square root of 2. Square root of 36 is 6 times the square root of 2. So the square root of 72 is equivalent to 6 times the square root of 2. Now, let's pick a different factor pair and see what would happen if we maybe forgot that 2 times 36 is a factor pair of 72. So let's pick this one. And I'm going to do the work in green next to it. So I can express it as the square root of 9 times the square root of 8. The square root of 9 is 3 times the square root of 8. And then what we want to check is the radicand. Is there any more perfect square factors? So in this case, 8 can be expressed as 4 times 2. So we can actually go one step further. Use a different color. So we'd have 3 times the square root of 4 times the square root of 2. So we'd have 3 times 2 times the square root of 2, which is 6 times the square root of 2. So even if you pick the wrong factor pair, you can still get the answer right. You just have to know to keep going. Okay? Always check that radicand before you box in that answer. Make sure that there's no more perfect square factors so that you cannot break it down any further. So what happens when we start to include variables in our radicand? How do we know when a variable expression is a perfect square? So a variable term is considered a perfect square if it has an even exponent. So the next question is why? Well, let's look at x squared. We've talked about how exponents are nothing more than repeated multiplication. So x squared is really x times x. And the idea of a perfect square is that we can break down an expression or a value into something times itself. Right? As I discussed earlier, square root of 25 is 5. Why is that the case? 5 times 5 is 25. So x squared, it would be x multiplied by itself. So now let's look at x cubed. That would be x times x times x. Okay, if I group two x's together, I would have x squared, but then times a singular x. It's not an expression multiplied by itself to get x cubed. X to the fourth, x times x times x times x. So we'd have x squared times x squared. A variable expression multiplied by itself would give us x to the fourth. So now when I have something like x cubed, how do I simplify that? Well, we're going to look for the largest perfect square factor. So in that case, I would be looking here, right? And I'd want to express x cubed as x squared times x. X squared is a perfect square factor, and then x is the remaining factor, right? And we just looked here that x squared is a perfect square. So hopefully that makes sense. Basically, if we expand out the exponent, right, it gives us some insight as to, right, group it together, something times itself, right? Some expression with x's times the same expression with x's. That is what makes it a perfect square expression. So simplify each of the following. So we have the square root of 25 times x to the sixth. So 25 is a perfect square, x to the sixth is the perfect square, right? Even exponent, we can express it as some expression in terms of x times itself. So what is this going to be? Well, the square root of 25 is 5, and then x to the sixth, the square root would be x to the third. Right? Again, just to write out one more time, x to the sixth would be the product of 6 x's. Right? We'd have 3 x's times 3 x's, so that would be x cubed times x cubed. Right? That would be the variable expression when multiplied by itself, gives us x to the sixth. So now we have the square root of 48, x to the ninth. So again, for 48, we can write out our factor pairs. So we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5, 6, and 8. Okay, so what factor pair has the largest square root factor? So that's going to be right here, 3 and 16. So we're going to express the square root of 48 times x to the 9th as the product of two square roots. So we're going to have a 16 and a 3. Now x to the 9th is not a perfect square. Right? We need to express x to the 9th as the product of a perfect square factor and then the remaining factor. So we can express x to the 9th as x to the 8th times x. And if you need to see that more, expand x to the 8th. Right? And convince yourself that x to the 8th is a perfect square factor of x to the 9th. So then x to the 8th goes in this square root. The variable x goes here. The square root of 16x to the 8th is then 4x to the 4th times the square root of 3x. Okay? Because x to the 8th, we'd expand out that multiplication. We have 8 x's, right? 4 grouped together times the other 4 grouped together. That would be variable expression times itself, gives us x to the 4th. Two more examples. The square root of 200, x to the 4th, y to the 7th. So in this one, let's try to do it without writing out factor pairs. So we're going to write it as the product of two square roots. So 200. So the largest perfect square that I could think of that goes into 200 is 100. And then the remaining factor is 2. X to the 4th is an even exponent, so that's a perfect square expression. And then y to the 7th, I could express that as y to the 6th times y. So it would be y to the 6th times y. And this is also a reminder, when we multiply terms with the same variable, we add their exponents. Right? So we also have to understand, if I multiply this back together, y to the 6th times y, y to the 6th plus 1, y to the 7th, we would get the original expression. Okay, so always good to think about things in both directions. The square root of 100x to the 4th y to the 6th is 10 x squared y cubed times the square root of 2y. And again, for those variable expressions, expand them out if you need to convince yourself why the square root of x to the 4th is x squared and why the square root of y to the 6th is y cubed. Last example, now we have three variables inside our radicand. So we have the square root of 98, x to the 5th, y to the 11th, z to the 10th. So again, let's try to do this without listing out the factor pairs. So the square root of 98. So 49 goes into 98. Right? 49 times 2 would be 98. 49 would definitely then be the largest perfect square factor. So we have 49 and the remaining factor of 2. X to the 5th is not a perfect square. It could be expressed as x to the 4th times x. So x to the 4th times x. Y to the 11th is not a perfect square. Again, it can be expressed as y to the 10th times y. Z to the 10th is a perfect square. So then we have z to the 10th. The square root of 49, x to the 4th, y to the 10th, z to the 10th is going to be 7 x squared, y to the 5th, z to the 5th, times the square root of 2xy. Now, how could this become more complicated? Maybe this started with an expression outside of the square root as well. Just bring that down, keep it in parentheses, and then multiply it by this expression after we take the square root. And that's all we have to do in order to simplify those types of expressions. So hopefully this helps. Hopefully we have our head wrapped around how we can simplify a square root expression. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.